Hello, and welcome to this episode in our series on practical reinforcement learning with Python. In today's video, I'm going to explain to you what reinforcement learning is, and I'm also going to try to show you how reinforcement learning differs from other paradigms of AI, such as supervised learning and unsupervised learning. So, reinforcement learning is defined as a paradigm of AI concerned with training software agents on how to take actions in an environment in a manner that will eventually maximize a cumulative notion of reward. And note very well the words or the phrases that have been boldened in the definition. So basically the whole idea of reinforcement learning is you create an agent and you drop an agent in an environment. You don't explicitly teach the agent what it means to take good actions. Rather, you reward the agent based on actions it takes through its interaction with the environment, and the agent is able to automatically learn how to conduct itself in the environment in a way that it is going to maximize the cumulative reward. So, like, the agent is going to try to behave in a way that when it sums up all the rewards it receives from the various actions it takes at time step t, or at the end, it is going to have the maximum possible cumulative reward. Okay, now usually when you hear of an agent, you might mistaken it to mean something like a robot or anything other than software. But almost in all cases, when we talk of agent, we are talking about a piece of intelligent software that interacts with an environment. I mean, for the start, this might sound quite high level, but as we go along in the episode, I'm going to show you practical examples, and then when we begin to write code to implement some of these algorithms, it will become clear how you distinguish between environment, the agent, actions, and then the reward. But the basic idea is you are training software agent on how to take actions in an environment in a manner that will eventually maximize a cumulative notion of reward. Okay, and reinforcement learning agents actually learns policies that govern the best actions to be taken in different states or in different time steps. Okay, so the whole idea of training an RL agent, or when we talk of training in reinforcement learning, what we mean is we are trying to build a mathematical model that the agent or the software is going to use to decide what action to take in any given state that it finds itself in. So that is what is known as a policy in reinforcement learning. It's just a set of rules that governs how the agent behaves based on the different situations that it finds itself in. Okay, and policies can be learned using deep learning. So there are so many ways of building these policies into the agent. There are tabular methods, and we also have deep reinforcement learning. That is when we build deep learning models to be able to approximate functions that translate from state to actions for the agent to behave intelligently. Okay, and reinforcement learning differs from supervised learning and unsupervised learning AI paradigms. They are different in the sense that mostly supervised learning has to do with building classifiers or regressors. And what this means is that you have to initially get a set of labeled data, which can be quite tedious to come up with. So you get these labeled data, and the supervised or the supervision in supervised learning is the fact that you need a human that actually goes through all these data sets and labels them so that it is able to train the neural network to know in which class to place which data point. And this helps the neural networks to make adjustment to their weight such that they're able to generalize to a lot of unseen data. Okay, so how reinforcement learning differs from supervised learning is that in supervised learning you actually begin with a set of labeled data, but in reinforcement learning you don't actually have to gather data. The data is gathered on the fly as the agent interacts with its environment, and it is also different from unsupervised learning. Mainly unsupervised learning has to do with clustering. So you throw a large data at a model or an unsupervised learning AI model. And what the model does is it finds patterns in the data that helps it to group the data into clusters. Okay, so if you have a number of customers and then you want to cluster them based on some pattern of their purchases on your site, that is when unsupervised learning come into play. And it differs from how we do reinforcement learning in the sense that in both supervised learning and unsupervised learning, there is no notion of reward. Okay, so what these models, especially supervised learning, does is at the end of the day, you train a model and then you feed it new data point, and the model is going to predict which class to place that data point in. So it is instructive. Okay, it is instructive. It instructs you that, hey, given this data point, I think it is a best fit for this class. Okay, but when it comes to reinforcement learning, it is an evaluative process. So the agent takes an action and the environment rewards the agent, and based on the reward that the agent got, the agent is going to learn that, okay, it seems this action I took is good. The whole idea of reinforcement learning is you drop the agent in an environment and you don't tell it anything about what a good behavior is. Rather, it learns automatically. So it's through trial and error. It begins by taking random actions, getting some negative rewards, and then once it gets a negative reward, it knows that this is not a good action. Once it gets a positive reward, it knows that this is a good action. So reinforcement learning is kind of similar to how humans learn. Okay, it is quite difficult to explain certain things to a child. You can only try as much as you can, but the actual learning comes when the child begins to interact with a physical environment and then is able to associate heat with fire. I mean, it is hard for you to explain to a baby how to stay away from fire because it is dangerous. But once they begin to interact with a physical environment, they touch ice and they feel it's cold. So they get a kind of reward, whether they like that feeling or not. They touch fire and they get to know that this is hot. And so they get a kind of reward based on how warmed or how it burns them. And then that reinforces the knowledge into them. So they learn to take the right actions by initially beginning with trial and error. But in other paradigms of AI, it is not based on trials and errors, and the models are actually instructive. So they tell you where to place a data point, as opposed to in reinforcement learning, where the model is evaluative. It evaluates the quality or the greatness of an action it took based on the reward it received. Now, it can be relatively cheap as there is no need for data collection. Like I explained initially, if you want to do supervised learning, then you have to start by gathering training data. But when it comes to reinforcement learning, there's no need for this initial step where you need to gather data and label them, because this can be one, tedious, and it is also expensive because you need to pay people. Imagine if you want to train a computer on how to distinguish between good bananas and bad bananas, then you need to have thousands or tens of thousands or hundreds of thousands of pictures of both good and bad bananas, and then you need humans to sit and manually label all these hundreds of thousands of images one by one before you can feed it into a neural network for the neural network to learn that this is a good banana and this is a bad banana. But when it comes to reinforcement learning, there is no need for this initial data gathering step, because the model or the agent learns by interacting with the environment. So it kind of builds the data on the fly by taking actions based on trials and errors. Okay. And it can also be expensive to train, but cost can be avoided by leveraging simulation environment. And I'm going to explain this more. So I said initially that sometimes when people hear agent, they get confused as to what we mean by an agent when it comes to reinforcement learning. And I stated that an agent is almost always a piece of intelligent software that is taking intelligent actions based on rewards that it receives from previous steps. Okay, now when it comes to reinforcement learning, I stated previously that it is cheap because there's no need to gather data, which is true, but it can also be expensive. For example, one area where reinforcement learning really shines is when it comes to robotics. So imagine you are trying to build a robot, and you're trying to train the robot on how to walk on 2 feet. Okay, now if you start with the actual robot, which has to learn based on trials and errors, then you risk destroying the robot even before it learns to walk. For example, imagine you put the robot on a bumpy terrain and then it has to learn how to maneuver its way on such terrains. It will fall, it might crash, it might be spoiled. Some sensors might be broken because you are actually doing live training in a real environment. But thanks to packages like OpenAI Gym, we have simulation environment where you can actually simulate all these things to train your agent before you put the agent or you upload the software onto the robot to try it out in the robot. So this is what I mean by RL having the potential of being expensive to train, but you can avoid that by leveraging simulation environment. And one last thing I want to talk about the paradigm of reinforcement learning is that reinforcement learning has the potential to drive us towards the goal of artificial general intelligence. So there is a big misconception about AI when a lot of people hear about AI and then they begin to talk about AI super laws and AI taking over humans and controlling humans. They actually understand AI from the perspective of artificial general intelligence, where you build an agent or you build a model that is able to carry out any intellectual task. Okay, but we are far away from that because now what we have is actually artificial narrow intelligence, and this involves building models that can do one and only one thing. For example, if I build a model to distinguish between two different types of bets, that is all the model can do. It can't do any other thing. And if I want it to use for some other thing, I need to retrain it on an entirely new data set. I might even have to change the structure of my neural network architecture. Okay, so we are far away from artificial general intelligence. But the power of reinforcement learning is the fact that it is very similar to how intelligent agents learn. Like we humans learn through trials and error. There are a lot of things we learned as children when nobody actually sat us down to explain to us how to identify them. We learned by trying and failing and then having some reward feedback from the environment. Like I used fire as an example, and in the next video I'm actually going to give you a concrete example so this understanding can really sink in. Okay, so basically people hold the view that reinforcement learning has the power to take us close to artificial general intelligence. So to recap, this video was about defining what reinforcement learning is. We talked about the fact that reinforcement learning has to do with training an agent to take actions in an environment in a manner that will eventually maximize its cumulative notion of rewards. And we also talked about how it differs from other paradigms of AI. And lastly, we also mentioned how it has the potential to drive us towards artificial general intelligence. So thank you very much for watching this. In the next episode, I'm going to give a concrete example of reinforcement learning so that all these things can come together and your understanding will be made perfect. So thank you and see you in the next video.